Supervised learning algorithms. Hey everyone, welcome back to the channel. Today we're diving deep into one of the core aspects of machine learning, supervised learning algorithms. Specifically, we'll explore three popular algorithms: linear regression, decision trees, and support vector machines, SVMs. We'll not only look at how they work, but we'll also discuss when to use each one and provide practical examples using real datasets. What is supervised learning? Before we dive into the algorithms, let's quickly cover the basics. Supervised learning is one of the most widely used types of machine learning. In supervised learning, the algorithm learns from labeled data, meaning the dataset includes both inputs and the corresponding correct outputs. The goal is to learn a function that maps input data to the correct output, so we can make predictions on new, unseen data. Examples of labeled data, e.g., predicting house prices based on features like size, number of rooms, etc. Linear regression. Let's start with linear regression. Linear regression is one of the simplest supervised learning algorithms and is used when we want to predict a continuous value. The model assumes a linear relationship between the input variables, also known as features, and the output. In simple terms, linear regression tries to fit a straight line through your data points in such a way that it minimizes the distance between the actual points and the predicted line. Equation of a linear regression line, y(x)mx plus b, with explanations of each variable. For example, say we want to predict house prices based on square footage. The algorithm will learn the relationship between square footage and the price by fitting a line. Shows a Jupyter notebook and a dataset, e.g., a housing dataset, and walks through fitting a linear regression model using Python's scikit-learn library. Decision trees tree structure growing, illustrating decision paths. Decision trees are more flexible and can be used for both classification and regression tasks. Visual diagram of a decision tree showing a simple binary split. Decision trees work by splitting the data into smaller subsets based on certain conditions. Each node in the tree represents a decision point, and the tree branches out based on different outcomes. At the end of the tree are leaf nodes, which contain the predictions. The advantage of decision trees is that they are easy to interpret and visualize. However, they can overfit if the tree becomes too complex. Let's look at an example. Here we have a dataset with information about customers, like their age and income. We can use a decision tree to predict whether a customer will buy a product or not. We fit the decision tree to the data, and as you can see, the tree makes splits based on the features. Support vector machines, SVM diagram showing data points and a hyperplane separating two classes. Finally, let's talk about support vector machines, or SVMs. SVMs are powerful and can be used for both classification and regression, though they are mainly used for classification tasks. An SVM works by finding the hyperplane that best separates the data points into different classes. The goal is to maximize the margin, which is the distance between the hyperplane and the nearest data points from each class. Illustration showing support vectors and the hyperplane in a 2D space. One key advantage of SVMs is that they can work well with both linear and nonlinear data, using something called the kernel trick. However, SVMs can be computationally expensive for large datasets. As you can see, the SVM finds the optimal hyperplane to separate the species. Here's a quick guide. 1. Linear regression. Use this when you need to predict continuous values, like house prices, and you believe there's a linear relationship between your features and the output. 2. Decision trees. These are great when your data is complex and nonlinear, or when you want an easy-to-interpret model. 2. They work well for both classification and regression tasks. 3. SVM. SVMs are best when you have high-dimensional data, or when you need to perform complex classifications. 3. They're especially useful when you have small to medium-sized datasets but need high accuracy. To sum up, supervised learning algorithms are fundamental tools in any machine learning toolkit. Whether it's predicting house prices with linear regression, classifying customers with decision trees, or separating complex classes with SVMs, each of these algorithms has its strengths. Logos of popular machine learning libraries like scikit-learn, TensorFlow, etc. If you found this video helpful, don't forget to like and subscribe for more machine learning tutorials. Thanks for watching, and I'll see you in the next video. Key takeaways. Linear regression predicts continuous values. 2. Decision trees. Useful for classification and regression, easy to interpret. 3. SVM, great for high-dimensional data and complex classifications.